Hello Unity developers, in this video I'm going to show you dual contouring, which is a new HAL generator as a surface model for Voxel. And here you can see the sample scene, a dual contouring. You can find it here, Fractalia Voxel generator. In the samples there is the how-to folder where all the new samples are, and you can see here dual contouring, and it's this scene here. If you want to use this HAL generator, I highly recommend to go to the dual contouring scene, take this, copy it, and paste it into a new scene. I can show you how to do it. New scene, as this would be now your scene. Paste it, and here it is. And I create here now a light just to see a bit, and the reflection probe. Here, reflection probe is here. Let me have some reflection. Let's make it like this. So, and what you can see here is the whole setup. There will be a prefab in the next update. I have created it here. In the current version, there is not the prefab. This setup contains everything you need for this specific kind of HAL generator. This is also was a suggestion from a customer to create whole setups instead of just the generators, so that you have the voxel modifiers here, the dual contouring, the textures. And you can see here, this is quite a lot. And there is a lot of stuff going on here. Let's start step by step with it. First, we can see here the voxel generator itself. This is nothing new. I can generate the world, load data, reset. Here, creating a block, load data, generating the world. And it looks weird, because you can see here there's a lot of stuff going on, and for now let's check out the HAL generator itself. Of course, it's part of the modular uniform visual HAL. In this case, you have here the meshed surface algorithm. If I change it to marching cube CPU, you can see how it looks like. And I simply select here now dual contouring CPU. Now it is here. The module itself has a surface point, optimized mesh, which combines all the vertices in, and it really lowers the vertex count. This is highly important when you use tree-planar mapping, because tree-planar is more expensive, and so you want to have less vertices. The disadvantage is that you cannot get nice UV coordinates anymore, because they are merged. And you can experiment with it, and you will see the result. The crease threshold here, basically this is related to the surface shading. This HAL generator allows you to mix flat and smooth shading. I can show it to you later on. And it uses the dimension. If you uncheck it, you can see here it has smooth shading, and if I change the threshold, you can see here you switch between smooth and flat shading. But I want to use the crease dimension, so that means that you can now paint smooth and flat shading. So this HAL generator allows this. Surface extraction mode. Here we can see now the really funny part. I uncheck this, and you have surface nets. Cubic flat, surface nets, QAF, whatever this is. These are the dual contouring algorithms. Some crystallic stuff, cubic, smooth, and snapped. Those are not individual HAL generators. This is still one surface model. It's just that the dual contouring allows the mixing of surface modes. And for this, I activate here mode dimension, and mode dimension is dimension 14. Here we have some other settings for the individual surface modes, also this Schmidt's iteration and Schmidt's step. I looked it up, also the individual algorithms. I am not sure what exactly this does. You can play around with it. And here for the crystallic, you have the seed and the amplitude. You can see I can increase it like this, but I like to prefer to keep it. You have use proper values. This is really, as a crystallic is really more for fun or game environments. Yeah. This is this. Here you have the normal the post-process modules. We have surface texture version 2 because it allows 12 dimensions. As in the other HAL generators, you also have multi-texturing, 8 normal textures plus 4 colors. UV mapping, I have it disabled because this one uses the G-planar material here. You can see here, this is 8 layers, 4 colors, G-planar, and that's why I have optimized mesh. Now let's start with the basics, and so the first thing is we have here 15 dimensions. Also 16, also 0 is 1 and 0 is a dimension, and so we are really on the brink edge of the amount of dimensions which are supported by default. And so if you need more, you can increase the slider, as the maximum value. It's up to you. So we already have 15 dimensions. Now, if we check here the voxel generator, I generate the world. What you can see here, yeah, blocky world. And if I take this here, now if I paint here, what I am doing here, I paint the mode itself. Here, if you see here, I paint with multiple voxel modifiers. The first one is the mode. The mode itself, if we check here the target dimension 14, depth 6, and the shape, if we take the targeting, always modify the shape module. Yeah, post-processing module, this is important, threshold. And here I want to, I discard left, and I want to set it to 4. So what this does now, it paints the value 4 onto the into the voxel block at dimension 14, and mode 4 basically is this crystallic mode. Here I have something called crease. The crease I'll show you later. Here I have now other ones for crystal, for a yellow crystallic, a blue one. I can paint with the white one. Here I have the normal density. Here is one for crease itself. And we have here one for the modes. So I have, that's why I recommend you to really use the setup from the sample scene, because you can see how complicated this gets. So you have really so many different kinds of HAL generators, also 14 dimensions. Cubic flat. Let's paint over it. We have a flat world. Average, I paint over it. You can see here a part of the volume is now smooth and a part of it is blocky. And the thing is, you have here, let me change it to shaded wireframe, just you can see how the transition happens. No? It transists, the block one transists to the surface one. Also this really works. QAF is a new mode. It looks like this now. It's also flat. It has this smooth surface, but it's a bit different. It looks similar, but if you in the shaded wireframe, you can see the difference how it looks like. This Schmidt's also the same. It also has a difference. Cubic smooth. Look, it looks smooth, but it is a cubic surface. You can see it here. Snapped is also some weird hull generator. Also, it looks cubic, but it's a different position. I think it has a different position. It's a bit strange. It's a cubic, but it is has a offset. And on top of it, of course, if I apply all of them, you have texture dimensions. That means I have here the dimension definitions: texture, grass, rock, snow, ice, lava, molten. This is how I defined it. Cliff, obsidian, color 1, 2, 3, 4. Crease shading, surface mode. Have this 14 dimensions with the overview. And now I show you crease shading. I take the average, I paint over it to have an average surface, and I make it shaded. And now I take this crease one here and paint over it. On this mountain, it's, I think, better visible. You can see here, you have here a flat shading. And if I subtract it, and if I add it, you can see it turns to smooth shading. It's now smooth. Here this has no texture on it. Here I think you see it better. Now it's flat shading. And now add this material and you have it smooth. So this is called crease. And yeah, so this is so you can have surfaces which have flat and smooth normals. So this is a cool feature. So it gives you another degree of freedom to manipulate the terrain. So for example, ice. The ice should be should have flat normals, should not be smooth. This one should be smooth, and you can see here this one is now. You can see the reflections of the ice, but this one should not be smooth. So here, look, you can see the one is. You can see the edges, and with full crease, you can see here also. You can see a smooth reflection, and without crease, you can see a flat, like gemstones. No? Yeah, so this is the. Well, you can see an overview of dual contouring. It's crazy what you can do with it, and it's really more efficient than the other one. As I tested it, it has a higher efficiency than so it's so from the performance. This is rank 1, then comes this one, then GPU, and then block crystal mesh. this is really extreme efficient as this dual contouring, especially if you uncheck mode and just use surface nets. You have a similar result like margin cubes. If I change it to CPU, you see no difference almost. It's a bit different, but it's really much faster, especially in infinite world. It's much more. The whole algorithm is simpler. This is the funny thing. It's a dual contouring. The paper itself is written in the most complicated way, but the algorithm itself is really much simpler and much easier for the computer. It does not have to do the lookups. The only thing what you have to watch out for is optimized mesh. I have a camera here. As an optimized mesh and non-triplanar mapping. I can show you this now at the end. Yes, I mean it is really more a showcase video. I change it now to the normal. To the normal triplanar. Of course, I need UV coordinates. So this is what you have here now. This is what you have because the mesh is optimized. You have here UV coordinates which are unsuited, and for this, when I uncheck it, yeah, you have proper UV coordinates. Also, you need this unoptimized. You have to uncheck it if you use stuff like the setup with the barycentric blending. This here, basically, if you want to have one voxel coordinate equals one texture, and you want to use barycentric coordinates, you also need to uncheck. You have to use the unoptimized version, because yeah, otherwise you get this. That's why in the sample it uses the triplanar mapping, because triplanar mapping has the perfect surface, and the increased rendering cost is offset basically by the ability of using optimized meshes. Optimized meshes basically weld the vertices together. So I can show you the difference. For this, I changed the height flags to don't save, so you can see the voxel pieces. I changed it now to unoptimized. Let's check the vertex. You can see here the amount of vertices and the amount of triangles. And if I change it now to optimized, yeah, is the optimized mesh. Then you can see, if you see it now, you only have now 5,800 vertices, so it's much more efficient to render. So this is a quite complex video, and the best thing is really to go into the sample, copy the whole setup, and use it in your scene. Don't create it from scratch, because you have so many options, so many individual objects, and even voxel modify version 2 must be set up with the threshold in order to be able to paint the mold, because you want to paint with a specific texture. So I recommend you to use the setup, and in the next update I will also add a prefab for the setups themselves, not the single voxel generator, because it's just too much as the amount of complexity. Of course, with more dimensions, with more freedom, the complexity increases. And at the end, if you load the data, you get something like this. Yeah, mode dimension. You get something like this. If part of it is blocky, part of it is crystallic. You have the textures. You have blocky area, you have smooth areas. You have different kinds of smoothness. You have smoothed cubics here. You have the density. So this is a lot of stuff. So take it slow and use the sample scene to get started, because you see how many options you have here. So I hope you like this video. Feel free to leave to comment on it. And I hope you like the voice quality, because I also bought a new microphone. And you will see more videos. See you later. Bye bye.